So the first thing we want to do is to sketch out our ellipse. The ellipse is x squared over 16 plus y squared over 25 equal to 1. So Carter, this ellipse, is it going to be vertically positioned or horizontally positioned? Perfect. So I'm going to go up 5 units. 1, 2, 3, 4, 5. Down 5. And then to the right 4. To the left 4. Oh man, your cell phone is going to drive me bananas. Okay. Okay. Part A says, this motion begins at 4, 0. So is that Billy to the top, to the bottom, to the right, or to the left? To the right. Perfect. It starts here. And it goes which direction, Braden? Clockwise or counterclockwise? Clockwise. So that to the right or to the left? Right. Up or down, I guess? Down. Down, yes. Okay, so like that. And it takes 2 full seconds, y'all, to finish. So if it takes 2 full seconds, how long will it take for it to be on this side? 1 second. Yep. How long will it take to go here on the bottom? Half of a second? Yes or no? How long will it take to be here at the top? 1.5 or 3 over 2 seconds. And then 2 seconds later, it's back to where it started. Okay. So there's some language in here that I do want to remind you guys. A revolution, guys, 1 revolution is the same as a full what? Circle. Okay. A full circle. Full circle. And a full circle, based on basic trig, is what radians? 2 pi. Would you guys agree with that? And that also means it's 1 period. Yes, no, or maybe? True, false? Yeah, all of those are the same language. Okay. Now, what is the formula for a period? How do we find? What's the formula to find a period for sine and cosine? 2 pi divided by b. Okay. All of that is related. It says here that we are supposed to write a parametric equation. So I'm going to make a chart. You don't have to. When you get really good, you don't have to make charts at all. At time equals to 0, what is the x value and what's the y value? Time. X is what? 4, y is 0. Do you guys agree with that statement? What's the next time frame for this object? Half a second later, yep. What is x and what's y? 0 and negative 5. Good. What's the next time frame? 1. What's x? What's y? And then next time frame is 3 over 2 seconds. X is. Y is. And then we're back to where it started at 4, 0. Now, because it is circular motion, we're going to deal with trig. Okay, so your parametric will have these 2 options only. It will be x equals a blank space in the front for amplitude. We can start with cosine and a blank space for your b value, your beta, times t. Or y equals blank. If x is already cosine, then y will be sine, or the other way around. X can start with sine first, and then if x is already sine, then y will be cosine. And so the blank spaces is what we fill in. And now we decide, is the first 2 equations, x equals y equals, or the bottom 2 equations? And we decide based on our information. We do have to find a b value, guys. What do we need to do to find beta? So A goes in the front, first blank space for all of them. B goes in second blank space. So how do we find beta?
Based on the equation of the
Yep. How long does it take? How many seconds does it take for us to complete a revolution? Yep. And so that's 2 seconds equals to, what's the formula to find beta? 2 pi over b. if we multiply both sides by b, is 2b equals 2 pi. So 1b is 2. Or is it pi? Pi. Okay. Pi goes in here. Whatever you use, it's all, for this one, it goes in there. Okay, it's just pi. Sometimes it's 1, sometimes 2 pi, sometimes 4 pi, sometimes have a pi. Does that make sense? It doesn't have to have a pi. It can be just a constant number. So we have to decide, is the first set or the second set that would be applicable for part A. So if you look at the chart, x is at the beginning of time. X is 4 and y is? Out of these, which one, cosine or sine, will give us a non-zero for the beginning of time? Which one will give us a non-zero when time is 0? Cosine or sine? Would you agree with this one? Okay, so we have to plug it in to see if it works. When time is 0, 0 times pi is? Cosine of 0 is? 1. It's not 0, right? And then when I plug in, time is 0 again, times that is 0, sine of 0 is? 0, right? So would you agree this is a better fit for that set of information? But then what would be the amplitude? So this is what we are going to use based on the information. What would be the amplitude? Again, at time equals to 0, what is the actual x value? It's not 1, it's actually what? 4. So your amplitude has to be 4. So amplitude has to be 4. Now we have to find the amplitude for y. Well, we know at time equals to 0, y is 0. Would you guys agree? But if I plug in 0 for this, every single time it will be 0. That's not true. It's not 0 for every single time. So we're going to move on to the next time frame at a half. At time equals to half, okay, cosine, what's half times pi? Pi over 2. Cosine pi over 2. 0 times 4. Is that okay to be 4 still? Yeah, totally. And then over here, half times pi is pi over 2. What's sine pi over 2? But I can't have 1 at a half second. Where's y? -5. So what is our amplitude for y? -5. You were right. And guess what? Those are our two parametric equations. Okay. After a few of these, you're going to be like, oh yeah, I know what the amplitude should be. Anytime you're dealing with circulars, it's always a trig parametric equation. All right, B. Eve, can you help us read part B, please?
The motion begins at 5:05, counterclockwise, and requires 1 second for revolution.
Perfect. I'm going to sketch it again because I do need to like mark it. So I'm going to sketch the same ellipse as before because it says the ellipse. Go up 1, 2, 3, 4, 5, down 5, right 4, left 4. Did you ever miss your dot? Just make it really fat. Okay. This time, it begins at 0, 5. So Dana is at top, right, bottom, left. Where would that be? Did you say top? Okay, starts here. Then it says counterclockwise, Allie. So is that to the right or to the left?
To the left.
Yep, so guys, this object travels this way. Okay. Again, a full revolution, Jordy, takes how long?
1 second.
So if you take 1 second, Jordy, how do we find B? 2 pi. 1 equals 2 pi. Do you guys agree with Jordy?
Over B.
Over B. So You're right, that's a formula. So that means 1b equals 2 pi. Right? Yes, no, maybe? All right, let's make our chart since it's the big, we just started it. All right, guys. If it starts on the top at time equal to 0, what's x comma y? What's x?
0.
Y?
5.
Ooh, yeah. The next halfway in the bottom here, what is the time frame for the bottom? 1/2 second. That means, what is the time frame here on the left side? 1/4 of a second. What is the time frame on the right side? 3/4. Yep. So those will allow us enough points to kind of put it in our chart. So we have 1/4 second, 1/2 of a second, 3/4 of a second, and then obviously back at 1. So at 1/4 of a second later, Brooke, what are the x and y values? Good. Josh, at 1/2 a second later, what are the x and y values?
0, -5.
Emily, at 3/4 of a second later, what are x and y's? And then we're back where we started. Perfect. Okay, so now look at this. Remember, we only have 2 choices, students, in our equation, okay? For this particular information, are we using the top 2 or the bottom 2? Why bottom 2?
Because our beginning is supposed to get side as in, or cosine as a non-zero.
Yes. Can you guys see it? For this piece, a y is a non-zero value. And in trig, only the cosine, right, out of the 2 will result in a non-zero. Okay, so it would definitely be the bottom. Blank sine blank of t, y equals blank cosine blank of t. For beta, do we know what to fill in? 2 pi. Yep, we found it earlier. Okay, now we have to fill in alpha. Which one's easier to fill in first? Y? Is y easier to fill in first? What is the amplitude for y? 5? Yes or no? Okay, we fill that in first and we can check. Okay, 5. When time equals to 0, 0 times 2 pi is what? Cosine of 0? 1 times 5? 5. Is that working? Yeah, let me make it look like a 5 because that looks like a funky number. Okay. What is the amplitude for x then? 4? -4. Make sure we check a few points, okay? All right. Is it working still if we, at time equals to 0? 0 times out of 0, sine of 0 is what? 0 times anything is 0. So that's it. Okay, that works for x, right? At time equals 0. Let's see if it works in a quarter, okay? 2 pi times a quarter is what? Pi over 2. Sine of pi over 2 is? 1 times -4? Okay, check. Let's see if it comes out to be 0. 2 pi times a quarter again is? Cosine of pi over 2? 0 times anything is? Is it working? Yeah, always check a few points to make sure they work. All right, and that's it. Box it up. All right, we are moving on to example 4. Annika, can you help us read example 4?
Given the parametric equations of a curve x equals sine t, comma y equals cosine t, where 0 is less than or equal to t, less than or equal to 2 pi, graphed indicate the orientation.
Perfect. All right, guys, how do we graph parametric by hand? We did a few already. Make a chart. Yep. Is our time limited? Yes. It's only from 0 all the way to. Yep. So you use the values that you don't need a calculator for. Okay, so x and y. All right, here we go. We are going to start with at 0. So when t equals to 0, sine of 0 is what, Kristen? Devin, cosine of 0 is what? Good. Bella, at pi over 2, sine of pi over 2 is? Cami, cosine of pi over 2 is? Perfect. Miss Lou, at pi, sine of pi is? Good. Nathan, cosine of pi is? Good. Cece, sine of 3 pi over 2 is? Good. Michael, cosine of 3 pi over 2 is?
0.
And then Katie, back to where it started. What are the x and y's?
0 and 1.
Beautiful. Let's graph it. Looks like the largest is 1, so I'm just going to make one tick mark all the way around. All right. Remember, it says show your orientation. So we want to plot when time equals to 0. When time equals to 0, x is 0, y is 1. This is your starting position. Does that make sense so far? Then the next dot decides whether you're going to go to the right or to the left, aka clockwise or counterclockwise. Okay, so 1, 0. So is this clockwise or counterclockwise? Okay, so one of my students did this. You think this is right? Please don't do that. We know it's not a square. All right, so put a few arrows to indicate clockwise orientation. And I think that's all it says, right? Orientation, graph. Yep, we're good. Let's move on. Example 5, not last. So in the prior notes, guys, I gave you guys the 2 parametric equations for projectile motion. I want you to find it, write it on the top. X equals, Y equals, right there. So find it in your notes. We took notes. We wrote it down. Let me shuffle your cards. Where it says projectile motion, and then I give you 2 parametric equations of x equals and y equals. There's a bunch of variables. We're going to write it, we're going to copy it again so we can use it. All right, Salva, what is x equals? So v sub 0 times? Okay. Yes, no, maybe? Yep. And then, Salva, what is y equals? Yeah, make sure make sure your notes is clear. All right, guys, let's talk about the variables. V subscript 0 is velocity initial. In our case, your V sub 0 equals what? 150 feet. Perfect. Okay, so it says it's suppose that Jim hits a golf ball with initial velocity of 150 feet per second at an angle of 30 degrees to the horizontal. So what is 30 degrees? Theta equals 30, yep. Okay. Now, based on our question here, someone give me what G equals. 32. How do you know it's 32 versus 9.8? Because you are in feet, right? If a problem's in meters, then you're going to use what? 9.8. Yep. What is H in this question, and how did you know that? How do you know H is 0? Right. It doesn't state, guys. It is 0 because you're hitting on the ground. You have a golf ball. Not true if... Okay, so let's say that this question may be a basketball player, right? Would you agree H may be different depending on how tall the basketball player is or where the ball is? But this one would assume the golf ball is on the ground. Good morning. Muchas gracias. All right. Part A. Emily, help us read part A.
Find
Perfect. So we already have the original. We have x equals, every time we see v sub 0, we put in 150. Cosine, every time you see theta, we put in 30 degrees. We will simplify that, but let's just fill it all out first. So y equals negative half. Velocity in this way is 32. T squared stays t squared. Again, we see v sub 0, 150. Sine of 30 degrees. And then, do we need to write plus 0 for h? No, let's leave it. All right, let's simplify. Cosine of 30 is, Josh, what is that? Good. So 150 times rad 3 over 2. Again, we'll simplify that out in a little bit. Half of negative half of 32 is negative 16. So that's negative 16t squared. Dana, sine of 30 degrees is 1/2. So, yep. All right, let's make it pretty. Final answer, students. Go ahead and write it all in. Box it up. X equals y equals.
Just leave it in graphical form.
Yeah, don't round. All right, Eve, what do you have for final answer for x and y?
For x, I have 75 rad t, and then y, I have negative 16 squared plus 75.
Perfect. Good job. You guys remember in Algebra 2 and Algebra 1, or even at the beginning of this class, you guys remember seeing all of the parametric equation always start out in negative 16? That's why. Okay, that's why it's always negative 16.
You have a 7 rad 3 and 75 rad 50.
Ooh, 75. Good job, Matt. All right. Good job, buddy. All right. B. Okay. Brayden, help us read B.
How long was the golf ball in the air?
How long was the golf ball in the air? So let's talk about x's and y. Parametric. X equals represents what? Horizontal or vertical for x?
Horizontal.
Horizontal displacement, horizontal distance. Y represents the height of the ball, vertical distance of the ball based on time. Okay. B said how long was the golf ball in the air? So how long means what? Time. We're looking for time. But which equation would we need to use to solve time? They both have time in it. The y, question mark, why? Yeah, that's how high it is. So okay, so question, how do we know the time of the ball in the air? Find the max height, but is the max height the max height?
Intercepts for y is equal to 0.
Find the x-intercept, right guys? Think about this. How high was the ball in the air depends on what? Yeah, when it lands back in the ground. Does that make sense so far? If it lands on the ground, what's the height? 0. So we make y equals to 0. Exactly. So make y equals to 0. And by the way, are we using x equals to y equals one more time? Y equals. So negative 16t squared plus 75t. Now all basic algebra. What do you think? How do we solve for t? Oh, that's too much work. Factor out your t. All right, what's left? Okay, now what? Solve, yep, how? Let's take each factor, set goes to 0. So negative 16t plus 75 equals 0. That means I'm going to move this negative 16 over. So 75 equals 16t. Divide both sides by 16. So t equals 75 over 16. And these are both seconds, right, guys? Which one can I keep? Can I keep both? Can I keep one? If so, which one? How come we're only keeping this one? What does the first one mean? Exactly. At beginning of time, your height is also 0. So in 75 over 16 seconds, that's how long the ball lasted. Part C. Brooke, have us read part C.
Where was the ball at its maximum height? What is the max height?
Beautiful. Good reading. How do we find this? Now we find the vertex, right, guys? Anything with maximum or minimum is always a vertex. Well, of which equation? The y again. Okay, so I'll copy that over. Y equals negative 16t squared plus 75t. Yep, find the vertex. But how do we find the vertex? X coordinate of the vertex is negative 2b equals, divided by 2a. Negative b divided by 2a. Oh, I said it all wrong. Sorry. All right, what's b? So negative 75 divided by 2 times negative 16. That is going to be positive 75 over 32. Is this seconds or feet? Seconds, okay? So it will reach its maximum height in 75 over 32 seconds. Would you agree? How do we find the maximum height? Plug it in to get your y. Yep, so y equals negative 16 t squared. So 7, this is where I'm going to need your help with your fancy calculators. All right, go ahead and plug it in. Now, that's why I normally don't want to round until the very end. Okay, here, if you have to round, can you round it 2 decimal places for me? All right, plug it in. Double check answer your team first before you write in your notes. If you need a calculator, I have it set up there. All right, Jordy, what do you have? 87.89 unit feet. All right, do you guys agree with that number? Is that an okay number to move on? Yeah, okay. Josh agrees. No? No? All right, let's try it. If it's a no, guys. Let me see how you enter it in. Okay, do 75 over 32. Do that first. Oh, you forgot the square. Oh, no, that's a 16. Where does 16 go? Okay, that's okay. And then you plus? Okay. Why don't we end it all in? So that way you're less confused here. Yeah, do 16. Oh, I think so. Yeah, you have a positive 16. Yeah, that works. All right. Allie, help us read part D, please.
Determine the distance of the ball traveled.
Ooh, now what? Use X because that's horizontal, but what did we plug in? The first time that we found X equals 75 rad 3 times T. What T did we use again, or did we find again? 6. Oh, 75 over 16. Thank you. All right, let's plug it in. 75 rad 3 times 75 over 16. All right, crunch the number. Give me your 2 decimal places again with the correct unit of measurement, please. One more time. 608.92. And then unit of time is? Feet. Feet? Oh, yeah, feet. Determine the distance. Oh, sorry. Yeah, sorry. Is that good? All of us agree with the number? All right, move on to E. E said using a graphing calculator to simulate the motion of golf ball. For this one, I'm gonna give you this is optional. Even on your homework, if you see this in your homework, you don't have to do it. Okay. So anytime it says to simulate it on your calculator, it's not required. Does that make sense? Okay. Last example. Sean, can you help me read example 6? Tanya.
Tanya, who is a long-distance runner, runs the average speed of 8 miles per hour. 2 hours after Tanya leaves the house, you leave in your car and follow the same route. If your average speed is 40 miles per hour, how long will it be before you catch up to Tanya?
Perfect.
Use a simulation of 2 motions to verify this.
Yeah, so again, use simulation. That's optional again. But we are going to write parametric equation for Tanya and you in your car. Tanya is a runner. Sounds like you're not a runner because you're in a car. Okay. That's actually a pretty fast speed, isn't it? All right. Again, x in all parametrics will be what kind of distance? Horizontal. Y would be what kind of distance? Vertical. So let's talk about y really quick for this application. Do we have a vertical distance for this application? No, right? Yeah, no. It's going to be the same road for these two, okay? So in an application, you can give it any constant number that you want. 0, 1, 5, 9, rad 3, rad 5, whatever. So as a class, what do you want to give our vertical distance? 0. You're right. I will give it 0 or 1 or 2, whatever. Now, if you're planning on doing this on the calculator or doing the simulation on the calculator, give Tanya a different value than the car, so that way you can see it on your calculator for the sake of just seeing it in the calculator. If Tanya has the same y value as the car, then both on the same line and you won't be able to see it. Does that make sense? So for this one, since we said simulation is optional, you can do 0 and 1 or 0 and 0 and 1 and 1. Doesn't matter. Same thing in your homework. If you see an answer in the book that has something, it doesn't mean that it's wrong or you're right or vice versa, okay? All right, Tanya, horizontal distance. How do we get Tanya's? What's her velocity? What's her speed? 8, yeah. And then times that to what? Time, yep. How about you in your car? Your velocity is 40, yep. But you left when? 2 hours later. So your time's delay after Tanya. Would you agree? So T is Tanya's time. Okay. Now we would like to know when you caught up with her. Catching up with somebody, meaning your horizontal distance must be exactly that. So how do we solve for time? Set equals, all right. 8t equals. Oh, must be my security app. Emergency alert. Oh, yeah. Sorry, I'm like a building lead for our security team, so I get to know firsthand. Okay. All right. So 40 times t minus 2. We're going to distribute the 40. So that's 8t equals 40t minus 80. We are going to subtract 40 from both sides. So negative 32t equals negative 80. I need more space. T equals negative 80 all over negative 32. All right, if you need to use a calculator, can you give me that decimal? Someone said something. 2.5. Okay, unit? Hours. Okay, is this how long it took you to catch up? No, this is Tanya's time. Would you agree? Then how long did it take you to catch up? Half an hour. You're right. So make sure we're very cautious of the question. Okay, so to find you take 2.5 minus your delay time of 2 hours. So 0.5 or half an hour. It's up to you. So in half of an hour, that's how long it will take you to catch up with Tanya. All right, that's an egg roll, guys.